When most people hear the term rock, they think of a solid inorganic object, generally one that could not be easily broken, such as this piece of granite. And in turn, the component compounds in any rock would be one or more set of minerals, which in this granite includes potassium and plagioclase feldspar, biotite mica, quartz, and hornblende. With this in mind, amount of ice on Earth, you might become understandably confused when I say that ice can also count as both a mineral and a rock under specific circumstances. In total, as of 2024, approximately 29,730,000 cubic kilometers of ice exists across the Earth. Of this, 26.5 million cubic kilometers of ice is in Antarctica, 2.9 million cubic kilometers is in Greenland, 170,000 cubic kilometers in the combined total of all other glaciers outside these two regions, and an additional 160,000 cubic kilometers of ice is locked in permafrost. If you were to take all of this ice and make a giant sphere of this mineral, it would have a diameter of 384.35 kilometers or 238.82 miles, which is just slightly smaller than mineral criteria, one of Saturn's larger moons, Mimas. But why exactly is ice both a rock and a mineral? First off, let's look at the 5 criteria a compound must meet to become recognized as a mineral. First, a mineral must be the solid state of a compound or element. For example, liquid sulfur that burns as a blue color at Indonesia's Ijen volcano is not a mineral, nor is water since it is in a liquid state. Second, a mineral must occur in nature and not only exist in a lab. Thus, cubic zirconium is not a mineral since it is made in a lab, while malachite is a mineral since it often occurs in naturally formed copper ore deposits. Third, a mineral must have a defined chemical composition. This could mean a native element such as gold, or a combination of multiple elements such as carnotite, which contains 5 such elements. Fourth, a mineral must have a uniform crystal structure. This means that while pyrite is a mineral since it contains an isometric crystal structure which often forms cubes, opal is not a mineral because it is amorphous, completely lacking a uniform crystal structure. Fifth, a mineral must be inorganic, meaning it cannot have formed within a living organism or have been manufactured by humans. This is why ice in a refrigerator is not a mineral, nor is calcite or aragonite, which forms the shell that grows on a living creature, but turquoise is. Ice has ice properties, a Mohs hardness of 1.5, meaning it is harder than talc but less than gypsum. Also, ice's crystal system is hexagonal.